Hello and welcome to the Unit 4, Section 12 video on transformations of linear functions. So in the last couple of sections we've talked about how we write equations of lines. And now what we're going to do is talk about how do we transform those equations once we have them. How do we change the equation to change where our line is or how our line looks. So there are some transformation rules, and it's going to be important to remember that we have what's called a parent function. A parent function is the simplest type of function that you can have for a family of functions. And in this case, we're talking about linear functions. We're talking about the linear function family. And your starting point is going to be f of x equals x, okay? Where f of x is, of course, y. You can write f of x as y. Our slope is 1, and our y-intercept is 0. It's right at the origin. So, how do we transform things? Well, in terms of translations, you can do g of x being our transform function is equal to x minus h, or you can do g of x is equal to x plus h. Okay, so we're adding or subtracting the h, and we're doing it within parentheses. We are doing it to the x itself. We're not doing it, say, outside of the x. We're doing it to the x. Okay, so how does that work? Well, for minus h, if you have a minus, it's a shift to the right by h units. If you have a plus, you have a shift to the left h units. So an example of how this would look, a shift to the right by 4 units would look like x minus 4, and it would be in parentheses. How it would look for a shift to the left, 7 units, would be x plus 7. So this kind of goes backwards to how you think it would go, okay? At least for left and right. Because the h follows a minus sign, then you're going to have 4 be positive here, so that is why it's a shift to the right, because it's a positive 4 following the minus sign. And then vice versa when you're going to the left. So let's do some examples using those rules. So if f of x equals x, we have our parent function. Describe the transformation that is happening in each of these. Well, since we have minus 3 here, we're going to the right 3. Since we have a plus 5 here, we're going to the left 5. Since we have a minus 6, we're going to the right 6. Okay? That's how you identify those. Now let's talk about up and down. So again, our parent function is f of x equals x. Now this time, we're not acting on the x itself, we're acting outside of the x. So we're going to have x plus k. Notice we don't have parentheses this time. And then we have x minus k. So if you have x plus k, we're shifting up k units. And then if you have a minus, you have a shift down k units. So an example of how this would look, if we're shifting up 5 units, it would simply look like x plus 5. If we were shifting down 2 units, it would simply look like x minus 2. So in these examples, here we have a shift down by 3. Oops. Down by 3. Here we have a shift up by 1. Here we have a shift down by 7 because it's negative. All right, in the next part, we are going to talk about what happens when we have a reflection or a compression. Okay, so again, our parent function is f of x equals x. So if we have g of x equals negative x, if we put a negative in front of our x, then we have a reflection across the x-axis. So an example of how this would look is that you would have g of x equals just negative x. Okay, that's about as good of an example as you can get. You just make it a negative. Now, talking about stretching and compressing the graph, that is done by your slope, whatever value you have in front of the x. So you're going to compress when your slope, or your a, is between 0 and 1. So if you have some sort of fraction that is less than 1, then you have a compression. You're flattening your line, okay? And the flatter you make your line, the closer to 0 you get, and by the time you get to 0, your line is horizontal. That would be 0 slope, in which case, technically, we don't have a linear function, we have a constant function. Now, stretching occurs when your value for a is greater than 1. So if you have a slope of 2 or 3 or 4 or even 5 halves, that's greater than 1, so you have a stretch. So an example of what a compression looks like, you would have a compression of 1/2 if your slope is 1/2. You would have a stretch of 2 if your slope is 2. Okay, so let's do some examples using these. So here, 3x, we have a stretch by 3. For negative 2/3 x, the negative tells us that we reflect, and the 2/3 tells us we compress by a factor of 2/3. All right, for the third example, the negative tells us that we reflect. And again, this is across the x-axis. And then we have a stretch of 2, or by 2. So now that we've gone through all these transformation rules, let's take a look at some examples and see if we can describe the transformations. So in this one, we've got a negative on the out in the front, so that's a reflection. In fact, what we could do is go ahead and write that for any of these that have a negative out in front. So that would apply to number 6, and that would also apply to number 8. All right, on number 1 here, we have a, in parentheses, +5. So we're moving left or right. And since it's plus, we're going to move to the left by 5. In number 2, we have a slope of 2/3. That's our a. And since it's less than 1, we are compressing. So we've got a compression of 2/3. And we have a -4 or a -4 on the outside of the x. No parentheses. So we are shifting down 4. For 3, we have in the parentheses -2, so we're going to the right 2. And then the +3 on the outside, so we're going up 3. For number 4, we have a slope of 2, or a value of 2. So that means we are stretch by 2. And then we are going to the left 1, because that's inside the parentheses. And then we're going down 10. For number 5, we are going to the left 10, because we're in parentheses. Outside of the parentheses, we're going up 4. Number 6, we've already determined reflecting. We also have a stretch of 4. And we are going to the right 3. For 7, we have a compression of 1/2. And we're going to the right 7. And then finally, for number 8, we said it was reflecting thanks to the negative. 4/3 is greater than 1, so we have a stretch of 4/3, and we're going down 3, since that minus is not in a parentheses. So that's just a little introduction to transformations. They're fairly basic with linear functions. We're going to get more into the difference between left and right and up and down. It's not much of a difference when you have a linear function, but it does make a more of a difference when you get to more complex functions such as quadratics, which we're going to get to in a few units here. And you'll see more of those in Algebra 2 as well. But for now, this is your introduction. This is how transformations work, and these are the things you look for. All right, next section, we are going to wrap up Unit 4 with looking at linear inequalities.